Page 11, number 51. Read the question and come back. Okay, in table tennis, the table is a rectangle 9 feet long and 5 feet wide. So our table is a rectangle 9 feet long, 5 feet wide. I'm going to start sketching that. So here we go. Here's the rectangle. Okay, now 9 feet long and then 5 feet wide. Next we have a tennis court, also a rectangle, is 78 feet long and 36 feet wide. Let's draw that. It's going to be much larger. And now we have 78 feet for the length and the width of 36 feet. The question is, are the two surfaces similar? Remember what you do with similarity. Proportions, proportions, proportions. Now your proportion should check whether or not those two figures are similar. It says explain. If so, find the scale factor of the tennis court to the table. Now let's go ahead and just figure out if they're similar first. I'm going to set up a proportion where I compare the lengths from the table to the lengths of the actual tennis court. Let's match things up before we get started. So we have our 9-foot length compared to our 78-foot length, our 5-foot width to our 36-foot width. I can set up my proportion any way I want as long as I keep things matching. So I could do 9 over 5 is equal to 78 over 36, or I could do 9 matches up with 78 the way that 5 matches up with 36. I'm going to do it the second way. So 9 over 78, and then we have 5 over 36. Now we can cross multiply and check to see if we get the same amount on both sides. So if I cross multiply 9 times 36 in my calculator, I get 324. Going to do the same with the other side. 78 times 5. 78 times 5. And we get 390. Those are not equivalent. So if they're not equal, that means the two figures are not similar because there's not a consistent scale factor. So I'm going to say no, okay, not similar, not similar, and my reason would be that there's no consistent scale factor. Okay. No consistent scale factor. You can also describe the fact that the sides are not in proportion, and they would need to be if they are similar. So you can also talk about the fact that the sides are not in proportion. That would be our second explanation. Sides are not in proportion. And they have to be in order for things to be considered similar. Now, the second part of this question says find the scale factor if they are similar. But since they're not similar, you don't have to do the second part of this. There is no scale factor. In fact, if you found the scale factor for the lengths, it would be different than the scale factor for the widths. So just to show you and further explain, if I considered this the new and this the old, because I want to turn the table into the tennis court, for example, I would be doing 78, which is my new, over 9, which is the old, to find the scale factor. 78 divided by 9, it's a quick and dirty way of doing it, is about 8.6 repeating. 8.6 repeating. Now, if I did the same thing with the widths and I did 36 over 5 in the calculator, 36 divided by 5, I get 7.2. Those two scale factors are not the same. So it can't be that the two figures are in proportion. all the sides have to be in proportion. All of the sides have to have the same scale factor before and after. So for all these reasons, these two figures are not similar. Let's move on. Number 52. Quadrilateral hawk is congruent to quadrilateral form. Then they tell us some measurements here. The angle H is 60, angle L is 152, and angle M is 42. What is the measurement of angle A? So we're looking for a missing degree measure. Now let's focus back on the fact that this is a quadrilateral. And let me draw it. Now I have no idea what this shape is going to look like, so I'm just going to make up some random figure. Okay, as long as it's four-sided, I'm going to be okay. So let me go ahead and label this figure as well. So it's called hawk. Let me start at the bottom as H, bottom left. Then I'll go clockwise, A, L, K. The second figure they're saying is congruent, right? Which means it's identical. It should have the same lengths for the sides. It should have the same angle measures for the ones that match up to H, A, L, K. So let's go ahead and draw the second figure here. So I'm going to try to make it look the same. Can't make any promises. Okay, that's definitely not as good. So let me try one more time. Okay, it's a little bit better. So we're going to match up the second polygon's vertices with the way that it's written for H, A, L, K. So notice that H is written first, so that should match up with F. So I'm going to put the F in the corner. Now if I go clockwise in the same direction as I did for hawk, it should all match up. But let's just check. A matches up with O, so I'm going to go here with O. L should match up with R because they're both listed third. And then K, which is the last letter, should match up with M, which is the last letter. Okay, so remember, all of these angles are going to match up. So H is going to be congruent to F. A is going to be congruent to O. L is going to be congruent to R. And K should be congruent to M. And the reason they're all going to match up and be congruent is because they told me in the prompt that the two quadrilaterals were congruent. Now let's put in the other information that they gave us about the angle measures. So angle H is 60, so I'm going to put in 60 degrees. Then they told us angle L was 152. Additionally, angle M is 42. So since they told me angle M is 42, that also means that its corresponding angle, angle K, is 42. Additionally, H and F are corresponding. So if H is 60, F is 60. And lastly, if angle L is 152, then angle R is 152. So for both of these quadrilaterals, I have all of the angles except for angle A, which is going to be the same as angle O. So the question is, we'll find angle A. So let's go ahead and just focus on this quadrilateral, and we're going to ignore the second one because we got from it everything that we needed. Basically, what we got from the second quadrilateral form is we got angle M of 42. Now, focusing back on hawk, we have to think about if it's a quadrilateral, what should all of the angles on the inside add up to? Because I'm only missing one. And the way that we figure that out is by using our sum of interior angles formula, which tells us to get the sum of all the inside angles, we're going to do 180 times n, which is the number of sides, minus 2. Since we have 4 sides, the way we're going to figure out the sum is doing 4 minus 2 times the 180. In other words, 180 times 2, which is 360 degrees. So all the inside angles should add up to 360 degrees. So all we need to do is figure out, well, what's left for angle A if we've already taken up 152, 42, and 60. So we're going to subtract all of those measurements from 360 to see what's left over. So let's go ahead and do that. 360 minus 152 minus 42 minus 60. In the calculator, 360 minus 152 minus 42 minus 60 equals 106. 106 degrees is left over for angle A, which would also mean that the measure of angle O is 106. Okay? But they're just asking for angle A, so I'm going to put in 106 and I'm done. The interesting thing about quadrilaterals is that the interior angles also have the same measurement as a sum as the exterior angles. So we know that for any polygon, all the exterior angles, okay, always add up to 360. Doesn't matter if it's a quadrilateral, a pentagon, a hexagon, a decagon. Exterior angles add up to 360 in any polygon. But in a quadrilateral, the interior angles also add up to 360 because of this formula for sum. So it's just an interesting thing to note. Let's move on to 53. Number 53. Find the value of x. Now, looking at the shape, we have 1, 2, 3, 4, 5, 6 sides. It's a hexagon. Now, the measurements that they're giving us are all for exterior angles. Exterior angles. Now, regardless of the number of sides, for a polygon, exterior angles will always, always, always equal 360. So it doesn't matter if it has 6 sides, 10 sides, 20 sides, it does not matter. All of these on the outside should equal 360. So to solve for x, we're going to set up an equation where we add together all of these exterior angles and set them equal to 360. So we'll start with 93 plus 46 plus 3x plus 62 plus 4x plus 47 equals 360. Combine like terms, we have 93, 46, 62, and 47. I'll grab my calculator to do all that. So in total, we have 248. And now let's add together all the x's. 3x and 4x. That gives us 7x. So 7x plus 248 should equal 360. We're going to subtract 248 from both sides. So 360 minus 248 equals 112. So 7x equals 112. We're going to divide both sides by 7. And x is equal to 16. So that's our final answer. They're not asking us to find the measurements of 3x and 4x, just of x. But we could go ahead and plug it in for each of these angles and know what the measurements are for the angles as well. Okay, let's move on to number 54. Number 54. Read and come back. Okay, so 54, the diagram below is the closest estimate of Flana Valley. I don't know where that is, but thank you. I'm going to get more information from the rest. Every grid line is 1 mile apart. Okay, so every time you see a box here, it's 1 mile. 1 mile lengthwise, 1 mile height-wise. 1 mile. The dog population of Flana Valley is 63,831. Okay, so I'm going to write down dogs equals 63,831. What is the density of dogs per square mile in Flana Valley? This is our ask. We're asked to find density, specifically in dogs per square mile. So the number of dogs divided by, that's the word per, you divide by square miles. And we know when we see square miles, we're talking about area, okay? Area. So what they're asking us to do in this question is to find the density, which is the same thing as population density here. We're going to take the population of dogs, so the number of dogs, and we're going to divide by the area of the land. Area of land. So right now, we have the number of dogs. It's 63,831. What we need to do is divide it by the area of the land, because they said square miles. Now, looking at this figure, we're going to have to figure out the area. Now, I notice that in this figure, it's not just one figure. What I see when I look at it is I see two pieces. I see the bottom portion, if I were to divide from E to O, and the bottom portion looks like a rectangle. The top portion looks like a triangle. So to figure out the area of the entire Flana Valley, what I'm going to do is I'm going to find the area of the rectangle, and then I'm going to find the area of the triangle, and I'm going to add them together. So starting with the rectangle, I need to count to figure out base and height, because the area of a rectangle is base times height, or length times width, however you want to refer to it. So I have 1, 2, 3, 4, 5, 6 boxes from S to U, which is the base of this rectangle, and 1, 2, 3 for the height from O to U. So I'm going to multiply 6 times 3. 6 times 3 is 18. So 18 square miles, or 18 miles squared, is the area of the rectangle. For area of the triangle up top, I'm going to do base times height divided by 2, because that's the area formula for a triangle. Now the base is from E to O. It's going to be the same, 6 boxes across or 6 miles across. Now for my height, I have to make sure I use a perpendicular height. So I notice here I have the height, which is 2 boxes. That's nice and perpendicular to the base of 6. So I can see that it's going to be perpendicular. So I'm going to use 2 as my height. So let's go ahead and do 6 times 2 divided by 2. You're going to get 20, oh, not 20, sorry. 6 times 2 is 12, divided by 2 is 6. So 6 miles squared for the area of the triangle. Let's add those two together, 18 plus 6, and we're going to get 24 miles squared as the entire area of Flana Valley. So let's put 24 miles squared as the denominator in our density, population density formula. And the top is number of dogs. So you'll see as we divide, we're going to get dogs per, divided by, per mile squared. So go to your calculator. We're going to do 63,831 divided by 24. We get approximately 2,659.625 as the number of dogs per square mile. So it's approximately equal to 2,659.625. The issue here is that we're talking about dogs per square mile. You can't have a fraction of a dog. So what we're going to do is we're going to round. Now we can either round up and say there's going to be about 2,660 dogs per square mile, or we can round down and not overestimate the number of dogs per square mile. I'm going to go ahead and round down to 2,659 dogs. Because if I round up, I'm really overestimating the amount of dogs I have per square mile. So 2,659 dogs is my final answer. Now, this was a population density question. We've seen it usually with population of people over the area of the land, like Florida or some random city. But here they use dogs. Now, you can use dogs as population. In the future, you're going to see a question using number of tents. We could talk about ants. We could talk about anything that occupies an area or a space of land. So just be familiar with the fact that population density doesn't just have to be population of people. Okay, it could be lots of things. let's move on to number 55. Number 55, find the value of x. Now I'm taking a look at this figure and I notice there's a bunch of angles on the inside of my shape. So these are interior angles. Now they're asking me to find x, and I notice there's an x here at 14x and there's an x at 18x. So that's where our x is. Now I need to think to myself, well, what should all of the interior angles of this shape add up to? And in order to figure that out, you have to first figure out the number of sides for your shape. Now we have, starting at 14x, 1, 2, 3, 4, 5, 6, 7, 8 sides for this shape. So n equals 8. The number of sides is always the same as the number of angles. Now, my formula to figure out how much all these angles should add up to is a sum formula that we've used in a previous question, number 52. The sum formula is 180 times number of sides, which in this case is 8, minus 2. So to get the sum, we're going to do 180 times 6. In the calculator, 180 times 6 is 1080. So the sum of all the interior angles is 1080. That's how much they all should add up to. 1080. So I'm going to set up an equation where I add all of these together and I set it equal to 1080. Now, I'm not going to go ahead and write out my equation. What I'm going to do is I'm going to start combining while it's still in the diagram. So I have to combine 133, 167, 138, 115, 151, and 120 in the calculator. And go ahead and do that. 133 plus 167 plus 138 plus 115 plus 151 plus 120 equals 824. So now we're going to add together all the x's. I notice there's only 18 and 14. So 18 plus 14x is 32x. So I'm going to do 32x plus 824 should give me 1080. Subtract the 824 from both sides, so 1080 minus 824 equals 256. So 32x equals 256. Divide both sides by 32, and we get x is 8. So our x value is 8. Again, this question, you had to know the sum formula, 180 times n minus 2. So again, that should be something that you're going to add to the back of your reference sheet as something that you need to memorize. Okay, let's move on to our last question on this page. Number 56. Now I'm going to warn you, this is going to require a bit of work, so if you want to do it on a separate sheet of paper, I would recommend that. Find the perimeter around Lake Placid. Okay, very straightforward. Finding the perimeter, meaning adding up all of the sides, getting the side lengths, adding them up. So find the perimeter around Lake Placid, which is approximately the shape of a triangle with the coordinates listed. Round to the nearest whole unit for your final answer. Now notice that these are really big coordinates, 100, 325, 60, negative 40, negative 70, 815. So it's very impractical to try and graph all of these. Instead, what we're going to do is we're going to create a sketch and we're going to go through our little trick in finding lengths of sides. So here's going to be my little graph sketch. Okay, so that's going to be my sketch. Now, I'm going to kind of approximate where all of these coordinates are going to go. So we have 100, 325. So I'm going to envision 100, 325. That's going to be somewhere around maybe here. Okay, and I'm going to go ahead and put down, this is 100, 325. All right, our next point is 60, negative 40. So 60, negative 40. I'm going to approximate that it's right here. And I'm going to write in 60, comma, negative 40. Now the last one is going to be negative 70, comma, 815. So negative 70 is going to be pretty high up. I'm going to approximate it's right there. And I'm going to label it in as negative 70, comma, 815. All right, so let's go ahead and connect all three of these side lengths to see what gets formed. Okay, so here's my triangle. Now we need to find the length of each side. You could do distance formula. You have a calculator, so you could do distance formula. But I've always taught you a little trick, which is Pythagorean theorem, if you're trying to find a length on a graph. Now remember, the trick is you have to create your horizontal line, your vertical line for each one of the sides that you want to figure out. Now that's not going to be very easy to count the boxes for the horizontal and the vertical. So instead, I'm going to use a little bit of a trick here. So I'm going to get rid of those two lines. Instead, I'm going to grab the coordinates, negative 70, comma, 815, and the 100 and 325. I'm going to go ahead and start by figuring out that length. The way that I'm going to do it is I'm going to stack the two coordinates on top of each other. So negative 70, comma, 815, and then 100, 325. Leave a little bit of room there between the two coordinates. Now my goal is to figure out horizontal and vertical distance. So you're looking to see how do you get from negative 70 to 100. Now you're going to take the difference of those two. So negative 70 and 100, you're going to be adding, definitely going up, you're definitely increasing, and you're going to be increasing by 170. It's going to take 70 just to get to the y-axis, and then another 100 to get over to where that point is horizontally. So you're adding 170 to get to 100. Now to get from 815 down to 325, you're going to be subtracting. So you're going to be going down. So if we subtract the two coordinates in our calculator, 815 minus 325 equals 490. Those are going to be your two distances. So it's going to be your horizontal 170 and your vertical 490. We use those two distances with the Pythagorean theorem to solve for our line segment. So if I do the Pythagorean theorem, 170 squared plus 490 squared equals c squared. I'm going to use my calculator for this. So 170 squared plus 490 squared equals 269,000. 269,000 equals c squared. So if I square root it, square root of 269,000, I get the length of c, which is what I want, the length of my first side. Now we're going to repeat this again, and let's start with 100, 325 to 60, negative 40. And we're going to do this to find this blue line segment now. So again, stack up your two coordinates to go ahead and figure out the length between the x's and the length between the y's. 100, 325 and 60, negative 40. Now remember, the only reason this is a little bit difficult is because you have to use more conceptual understanding to figure out the length of A and B in order to use your Pythagorean theorem to get the lengths. Otherwise, if these were easy numbers, we could graph it, count the boxes, and find the perimeter pretty easy. But because these are such big numbers, that's why it makes it a little tricky. So let's go back to figuring out the distance between 100 and 60. Now we're definitely going to be subtracting. We're going down. So 100 to 60, you're subtracting 40. You could do 100 minus 60 in your calculator. To get from 325 to negative 40, again, you're definitely going down. You're going to be subtracting. So to find the difference here, you're going to add together 325 and 40. So in your calculator, you could do 325 plus 40, and it's going to be 365 that you're decreasing by. So let's go ahead and take those two numbers, 40 and 365, and those are going to be our A and B value. So if I drew a diagram here, the horizontal would be 40 boxes, and then vertically, it would be 365 boxes for your A and your B. So 40 squared plus 365 squared equals C squared. In the calculator, 40 squared plus 365 squared equals. So that's going to be our C squared. So I'm going to just go ahead and skip a step because we've done the Pythagorean theorem many times. And our answer is going to be the square root of this number in the calculator. So square root of 134,825 is going to give me C. All right, we have one more side length that we need to figure out. So this would be our last side length right here. So we're going to grab the negative 70, 815 and the 60, negative 40. Give myself a little bit of room. Okay, so for our last set of coordinates, we have negative 70, comma, 815. And then we have 60, negative 40. Okay, so to get from negative 70 to 60, we're definitely going to be adding. And since one's positive, one's negative, you can do a little trick to find the distance between them, which is adding them together. So in the calculator, ignore the negatives. You're going to add 70 and 60 together to figure out the distance between them, which is 130. And you know you're increasing because you're going from a negative 70 to a positive 60. Let's do the same thing for the other set. 815 down to negative 40. Well, you know you're subtracting. And since one's positive, one's negative, the quick and dirty way of doing this is by adding together the 815 and the 40, ignoring the negative. So 815 plus 40 equals. So it's going to be 855 that you're decreasing by. Let's use those two amounts, 130 and 855, to find our C. So we're going to do 130 squared plus 855 squared equals C squared. 130 squared plus 855 squared equals. So it's going to be square root of 747,925 equals the C. All three of these numbers, all three of these lengths need to be added together in our calculator in order to find the perimeter, okay? So we have to add all three of those lengths. Don't forget they're all square rooted. Now, 747,925 is already in the calculator, so I'm going to hit square root, and it tells me it's approximately 864.8. Add to that the square root of the 134,000. So 134,825 square rooted is approximately 367. Okay, add that to the 747 by clicking equals. Last one, the 269,000. So add 269,000 square rooted. It tells you that's the square root of 269,000. And now you're going to hit equals to make sure they've added everything together. Equals. That's going to be our final answer. Now we have to round this appropriately. So it told us to round to the nearest whole unit. So the whole unit is where the 0 is. We're either going to keep it at 0 or round up to 1. The 6 to the right of it says round up. So our final answer is going to be 1,751 units. I don't know if it's miles, inches, feet. It's just regular units. They didn't give me a conversion. So 1,751 units. So make sure you understood how I did the calculator work, because I had such big numbers that if I had to write it down every single time I did a square root, that would take me a lot more work. If you want to do that work, go ahead and do it. It's a great way to make sure you didn't make any calculator errors. But watch again the video on how I put it into my calculator to make sure that you know how to do it when you get to the test. Okay, so we're done with page 11. Let's move on to page 12.